Okay, so now let's move on and talk about variables. When we do research, we need to talk about variables. So what are variables? It's observations of physical, attitudinal, and the behavioral characteristics that can take on different values. Now this is kind of confusing. So let me just tell you a very simple version. A variable is a factor or a thing that we want to study. When we do research, we want to examine, does X, can be anything, right, causes Y? That's always the research question. And X and Y are variables. So for example, does eating carrots make you become healthier? Right, like this, become healthier. All right, those two are variables. We need to think of some way to measure the variables, but more about it later. So actually, let's talk about quantifying variables. We have to quantify the variables we want to study. In other words, transform them into numbers. There are 4 possible ways. Some ways are better than the other. Now, the first one is nominal variables, and those 4 ways are very important. Please remember. First one, nominal variables, in other words, categories, or names as their values. So for example, you see we do some research on 3 animals. So we give pigs as number 1, cows as number 2, and dogs as number 3. Now, 1 is not bigger than 2, and 2 is not bigger than 3. There's no real value. It's just category. Okay, those values do not imply any quality. Right? Now, ordinal variables is ranking. So, for example, The Biggest Loser, if you ever watched that program, competition in 2014, the first place lose some 59.62% of body weight. The second one is 54% and so far, and the third is 52%. This order, right? Ranking. Now the distances between ranks are not equal. So the first place and the second place, the distance is not equal to the second and third. Okay. The third way is interval variables, and we prefer this, at least this measurement, or number 4, we're going to talk about later. Interval variables, differences in the numbers, represent real differences in the variable. So for example, temperature. You see this temperature? The difference, the distance between degree 15 and 10 is the same with between 5 and 0. Okay, and then the best one is ratio variable. It has all the properties of interval variables plus a true 0. So for example, people's height, weight, reaction time, it's just pure numbers. Yeah, if we have numbers, it's much easier for us to analyze it. All right, so why do we need to know this? Different variables require different statistical analysis. Okay, and as I said, interval and ratio variables are way more preferable, more informative, and easier to analyze. Okay. Now, if you are doing research, we always ask, does X cause Y? So we manipulate X and see how Y turns out, right? In research, this X is called independent variable, or IV, and the Y is the dependent variable, DV. So for example, this sentence, this research question, does eating carrots make you become healthier? Now, which one is the IV, which one is the DV? Actually, eating carrots is the IV, and healthier is the DV, right? Health, person's health. Now, take a look at another example. Does monetary reward influence motivation levels? You give people more money, they are more likely to perform better, right? Now, in this case, what is the IV? What is the DV? See the same. Monetary reward will be the IV, and motivational levels will be the DV. Okay. Now, be careful. We have to be sure it is the IV and the IV only that causes the DV. If we don't control well, another evil variable might also be able to explain the changes of the DV, and we call it confounding variable. And we're screwed. So, for example, does eating carrots make you become healthier? Now, usually the research design will be, we divide people into two groups. Now, one group eat carrots, the other group take a placebo, right? The people who eat the carrots eat the carrots for months, and then we measure their health, right? Now, okay. By the way, what is the placebo? Placebo is something, in this case, okay, something looks like carrots, smells like carrots, tastes like carrots, but not carrots. I don't know how to define it, but you know. Now, if we divide the people based on their age, right? So this group are old people, this group are young people. Young people eat placebo, old people eat carrots. And then we compare their health a month later. What will be the confounding variable? It will be the people's age. Now, when we see the result, we don't know the result is because of the carrots versus placebo, or because of the age. So this is a very bad design. Yeah. We need to do the random assignment. More about that later. But the age is the confounding variable. Okay, so we're going to move to recap, and I will have my assistant Chelsea to preside this section.